All right. So, hi guys, we are back once again, and we are starting with our new topic, statistics, grade 11, but also examinable in grade 12. Okay, so let's get going. What is statistics? What is statistics? I mean, statistics is all over in this world. So statistics help us make sense of large amounts of information. Okay, but where does this information come from? Okay, so statistics basically deals with collecting, organizing, analyzing, interpreting, and also presenting data. Okay, so statistics helps us to draw conclusions or make decisions based on that information that we collected, that we organized, and all of that. All right. So, firstly, I want us to start from the scratch and know how to calculate some of the things here. Okay. So let's start with mean. Mean. Average mean. Okay. So, to calculate mean is very simple. Okay, so how do we calculate mean? Okay, so let's say for example, I will use this numbers as my example. So that is 143, 171, 182, 155, 171, 150, 188, right, 164, 180, 100, and 190. So this is a type of data that is called ungrouped data. Okay, so this is ungrouped data, and whatever that I'm gonna say here about mean is for specifically this type of data, which is ungrouped data. Of course, we have two types of data, that is ungrouped data and grouped data. So to calculate mean with ungrouped data is different from calculating average mean with grouped data. So whatever that I'm going to say here is specifically for grouped data. Okay, so how do we calculate mean? Mean is denoted by this symbol. This is average mean. Okay, so mean is calculated by adding up all the numbers. Okay, so all these numbers, we need to add them and divide by how many numbers there are. So we add the numbers, then divide by the number of values. Okay, so mean is equals to sum of all values. Okay, sum of all values divide by a number of values. This is how we calculate average mean for ungrouped data. Of course, number of values. So if in this case we want to calculate the average mean, we will add all these values and then divide by the number of values. So let's do it together. So we need to add 143, 171, 182, and then all those numbers. And after that, divide by the number of these values. How many values in this case? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you will divide by the 11. Okay, so you will add all the values, then divide by the number of values, which in this case is 11. Okay, so this is how you will calculate the average mean for ungrouped data. So again, for ungrouped data, please ensure that your data is always in ascending order. What are we saying? We are saying that your data should always start from the smallest value to the biggest value. That is ascending order. Okay, so this is how this is everything about mean for ungrouped data. Okay, and then I want us to talk about again median. So what is median? Median is a major term. Okay, so that is median, a major term. Okay, so this middle term is the value or the term below which 50% of the items in a set of data falls. So in simple words, we are saying this is a middle term. The reason why we call it a middle term is because it contains or it weighs 50% of the items, okay, in a set of data. So 50% in a fraction, that is 1/2. So with the example, with this example here, how can we try to find median, the middle term? So firstly, you need to know how many values are in this case. So we said we have 11 values. Then after finding the number of values, you need to be able to classify that number as an even number or an odd number. Okay, so what is even number? Even number is a number that can be divided by 2 with no remainder. For example, that is 2, 4, 6, 8. So these are your even numbers. And then odd number is a number that cannot be divided by 2. It cannot be divided by 2 evenly so. And there is a remainder of 1. For example, 1, 3, right? 5, yes, 7. Okay, so these are your odd numbers, etc., etc. Right. So now in this case we have 11. That is the number of values. We have 11 values. So if you if in this case we have 11, that is very, very simple, because we know 11 divided by 2, that is equals to, I think it's 6,5. Yes, 5,5. Ne? Yes, that is 5,5. So that is 5,5. So you will divide 11 by 2, that is 5,5, and then round it off to one decimal place. Yes, you will round it off. This is 6, right? When we round it off, then let's see which term is in position number 6 from the left hand side, right? So that is 1, 2, 3, 4, 5, 6. So that is 150 in position number 6 from the left hand side. And let's try again to find the value that is in position number 6 from the right hand side. So we will start here. 1, 2, 3, 4, 5, 6. So this means that 150 is our median. Okay, so that's very simple. If you have odd number, trust me, it's very, very simple to find the median if you have an odd number. So in this case 11 is our odd number, then you divide by 2, then you round it off, it's 6, then you find the value that is in position number 6 from the left hand side, and also check the value that is in position number 6 from the right hand side. If they are the same, then that means you are safe. So in this case, 150 is our median. All right. But what if in this case we have an even number? So if you have an even number, for example, 1 2 3 4, yes, let's take this example, 2 4 6 8, 2 4 6 8. If you have an even number, one, let's count the number of values. We have 1 2 3 4. So in this case we have 4 values, and we said 4 is an even number. So you will divide 4 by 2 and you will get 2. Let's count. Let's count. What is this? Let's count, or let's try to identify the value that is in position number 2 from the left. 1 2, as you can see, it's 4. And again, let's try to find the value that is in position number 2 from the right hand side. That is 1 2. So as you can see, 6 again is the middle term from the right hand side. So we've got 2 values that are in the middle, or that are in middle. Okay, so if you have an even number rather, you will count just like I did here, and then you've got 4, then you will add it with 6, then divide by 2. Okay, and then after that, in this case, that is 10, it's 5. Then check the value that is in position number 5. That will be your median if you have an even number. Okay, you will add those 2 values that are in middle, then divide by 2, and then the answer that you will get is the position. Then check the value that is in that position, in this case the position number 5. So that is the first method that we can use to calculate, or that we can use to find the median. The second one, we said middle term is the term which contains 50%, and that is 1 over 2. So you can use the formula which says 1 over 2 n plus 1. Okay, this is the formula that you can use to try and find the middle term. What is n? N is the number of values. Okay, we usually say n is total frequency. That is number of values, by the way. Okay, so in this case, remember we have 11 values. Okay, so you will substitute 1 over 2, 11 plus 1. And then that will be 1 over 2, this is 12, and then this is equals to 6. The term, or the answer that you got here, this is the position. Please guys, this is position, is not the final value. You cannot say 6 is your middle term. It's the position. So you will check which term is in position number 6. As you can see, 150 is in position number 6 from your left hand side and also from your right hand side. Therefore 150 is your median. Okay, so you can use the formula, and also this formula is very, very important in grouped data, where you need to estimate median in the cumulative frequency. Okay, that is Ogive graph. Okay, right, so you can use this method of calculating even number and then odd number divided by 2 and all of that, or you can use the formula. It's your choice. So that's all about median. Okay, that is middle term. So let's move to mode. Okay, what is mode? Mode is the value or the number that appears the most in a given data set. Okay, a number that appears the most. So this one is very, very simple. You will see in the data, ungrouped data, there is always a value or a number that appears the most, and that number that appears the most should be the mode. So this is a number or value that appears the most in a given data set. Okay, so this one, very simple. Mode, that is a number or a value that appears the most in a given data set. Okay, and then we have the measures of spread. Okay, we have range. What is a range? Range is the difference between the highest number and the lowest number. So in statistics, the highest number, we call it maximum number. Okay, number or maximum value. So we are saying a range is the difference between difference. The fact that we are saying difference, therefore, that is a minus. So range is therefore equals to maximum number, that is the highest number, minus lowest number, which in this case is called minimum number or minimum value. Okay, so this is how you will try and find a range, that is maximum number, which is the highest number, minus minimum number, which is the lowest number. So from our example here, what is the highest number? I believe that is 190. And what is our lowest? I believe that is 100. Yes, 100. As you can see, this is not arranged in ascending order. It is our responsibility to make sure that the uncrouped data is arranged in ascending order. So 190 is our highest number, which means 190 is our maximum number, and then 100 is our minimum number, which is the lowest number. So if you were to calculate a range, you will say 190 minus 100, and then that's your range. The answer you will get is your range. Okay, yeah, that is how you can try to calculate range, maximum number minus minimum number. Okay, before I can try to talk about this, I want us to talk about the 5-number summary. 5-number summary. 5-number summary. This is used to represent data. Okay, 5-number summary. All right, 5-number summary. So what are a 5-number summary? That is minimum value, the lowest number, that is the first number summary, and then the second number summary is what we call the lower quartile. Now, lower quartile is the number or the value below which 25% of the items in a given data set falls. Remember, median weighs 50%, right? So lower quartile in this case will contain 25%, and 25% is 1/4. Okay, so lower quartile is denoted by Q1. Okay, that is the second number summary, and then the third number summary is median. So at least by now you know what is median. So median is denoted by Q2, Q1 lower quartile, Q2 median, and then number 4, number summary, number 4 is what we call upper quartile, upper quartile, upper quartile. Right. So what is upper quartile? Upper quartile is the value or the number below which 75% of the items in a given data set falls. Okay, median 50%, lower quartile 25%, and then upper quartile 75%. Okay, median 50%, lower quartile 25%, upper quartile 75%, which is equivalent to 3/4, and upper quartile is denoted by Q3. Q3. Okay, and then lastly we have maximum value. So now, good people, this is our 5-number summary. Minimum value, lower quartile, median, upper quartile, and maximum value. So to represent this 5-number summary in a visual representation, we use what we call a box and whisker plot. So what is box and whisker plot? This is a visual representation of the 5-number summary of a data set. Okay, so you need to be able to know how to draw a box and whisker plot. Okay, but before we come there, I want us to know how to identify lower quartile and also upper quartile. Okay, so let's continue with that example of 143, 171, 182, 155, 171, 150, 188, 164, 180, 100, and 190. Before we can do anything in this case, we need to arrange this in ascending order. Please guys, this is very, very important. So let's arrange this in ascending order. What is the minimum value? The lowest, that is 100. So we are going to start with 100, then cancel it here, followed by 100, followed by 143, right? Yes, 143, cancel it here, followed by 150, I believe. Yes, 150, cancel it here, and then followed by 155. Yes, cancel it here again, followed by 164. Yes, and okay guys, so please note that, remember, we try to I tried to show to you how to determine or how to identify median, and remember our data was not in ascending order. Please ensure that your data is in ascending order. Okay, first, before you can try to determine the median, lower quartile, upper quartile, and all of that. So we have 164, let's cancel it, and then 171, yes, and then 180, yes, and then 182, yes, and then 188, and then lastly maximum a value of 190. So this is now arranged in ascending order. I want us to try and find lower quartile first. Lower quartile, 25%. It weighs 25%, and we said 25% is equivalent to 1 over 4. So this is the formula that you are going to use to find lower quartile. 1 over 4 into n plus 1. We said n is number of values or total frequency. Okay, so in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why 10? I thought we had 11. Okay, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is there anything missing here? 143, 171, 182, 155, 171, 150, 188, 164, 188, yes, 164, 180, 100, and 190. Hi guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, 11. We have 11. We have 11 as number of values, so we will put 11 here. Remember, we're trying to find the lower quartile, so that is 1 over 4 into 11 plus 1, so that is 3. So what is this 3? Position. At position number 3 we have lower quartile, so that is 1, 2, 3. As you can see, 150 is our lower quartile. I know we got 150 initially as our median, but that was totally wrong because our data was not arranged in ascending order. So in this case 150 is our lower quartile, which is of course Q1. Okay, and then what is our Q2? Q2, remember, it's median. Okay, so median 50%, so that is 1 over 2 into n plus 1. Okay, and then this is 1 over 2 into 11 plus 1, and then this is equals to 6. Yes, so this is 6 at position number 6. Let's check. 1, 2, 3, 4, 5, 6. That is 171. So it means 171 is your Q2, which is median. Okay, yes. And then let's try to find our upper quartile, which is the number below which 75% of the items of a given data set falls. Okay, so 75% is equivalent to 3 over 4. So that is 3 over 4 into n plus 1. Okay, and then this is 3 over 4, 11 plus 1. This is equals to 3 over 4 into 11 plus 1. This is equals to 9. At position number 9, we have our upper quartile. So this is 6, 7, 8, 9. So it means our upper quartile is equals to 1 Q3, which is Q3, right? Is equals to 188. Okay, that's good. And then our minimum, we said minimum value in this case is 100. That is the lowest value. And then the maximum value is 190. So after finding this, it will be very, very simple to draw your box and whisker plot. You just have to choose the correct scale. Yeah, you just have to choose the correct scale. So let me try to do that. Correct scale. I don't have a ruler with me, but you have to choose the correct scale. So we said 100 is our minimum value, so I'll just do this 100. Okay, and then we said what is our Q1? 150. That is our upper quartile, I mean lower quartile. So that is 150, and then I'll put this, and then followed by the middle term, which is our median, 171. Okay, so I'll say 171. There's my 171, followed by Q3, which is upper quartile, 188. So there's my 188. Remember, you have to choose the correct scale, guys. I don't have a ruler with me. Of course, I can't again draw in this case. But in your answer sheet, please ensure that you use a ruler with a correct scale. And then lastly, I've got a maximum value of 190. So that is 190. Of course, you can use a ruler here. I'm just gonna try and show you how to draw box and whisker plot. Okay, and then there's your box and whisker plot. Okay, yes, so this is your box and whisker plot. Please note that they can say comment on the skewness of the data. There is positively skewed and there is also negatively skewed. Positively skewed, okay, and also negatively skewed. So if your skewness is positive, then this means that positively skewed, then this means that most score or most values or most numbers lie to the right. Okay, so of course there are some of the people that can be able to identify that most score lies to the right, but to be more safe, if your skewness is positively skewed, then this means that your mean is greater than median. Okay, so if your mean is greater than median, you can of course compare, find mean, and then try to calculate or try to find median. And then if your mean is greater than median, so this will therefore show you that your skewness is positively skewed. Okay, and then we have negatively skewed. So negatively skewed, most score or most values lies to the left, and if this is the case, then mean is less than median. So please compare, please ensure that you always compare to be safe. You have to compare the value of mean with the value of median. If the value of mean is less than the value of median, then that is negatively skewed. But what if mean is equals to median? If mean is equals to median, then we are saying, when we comment on the skewness, we are saying the skewness is symmetrical. Okay, symmetrical, everything is balanced. Okay, so mean is equals to median, but it's very rare to find this. Okay, mean is equals to median. So that is the box and whisker plot. And let's talk about what we call the interquartile range. Okay, the fact that it's a range, therefore this is maximum minus minimum, but we are talking about interquartiles. And remember, we have upper quartile, which is denoted by Q3, and we have a lower quartile, which is denoted by Q1. So how are we going to calculate interquartile range? That is upper quartile minus lower quartile. I mean, think about it. Upper quartile is bigger than lower quartile. So if we are being specific, okay, we are being specific, talking about interquartile range, okay. For interquartile range, Q3, which is your upper quartile, is the maximum value because it's greater than Q1, and Q1, which is the lower quartile, is the minimum value because it's smaller than Q3. So hence we use this formula when we are calculating interquartile range, Q3 minus Q1. Okay, so here we set our Q3 is 188, so 188 minus Q1 is 150, therefore you will get the value of your interquartile range. Okay, then I want us to talk about outliers and of course standard deviation. Outlier. What is outlier? Outlier is a number in a set of data that is very, very, very different from the rest of the numbers. Why? Because this number can either be much bigger or much smaller than the other numbers. That is outlier. So how can we find this number that is very, very different from the rest of the numbers that are given to us? Okay, we use the formula which is Q1 minus 1,5 multiplied by the interquartile range. Okay, and then we are trying to make an interval, and then we have Q3 plus 1,5 IQR. So this is how you will find the outlier, a number that is very, very different from the rest. It is either much bigger or much smaller than the other numbers. Okay, so I'll just take an example and show you how to identify an outlier, because of course you know what is Q1, that is lower quartile, interquartile range, you know it, Q3 that is upper quartile, and then standard deviation. Standard deviation is a number that represents how far a set of numbers have spread from the mean. Okay, so it shows us how far a set of numbers have spread from the mean. That is standard deviation, and it's always denoted by the symbol. I don't know how to draw it, but yeah, that is standard deviation. Deviation. So I'll show you just now how to find standard deviation. So let's take an example here. I've got an example here. Yes, my example. After utilizing GeoGebra to teach geometry, the 14 participants' marks out of 100, yes, are displayed in the table below. Okay, 14 participants, that is the total frequency, which is our n. All right, as you can see, our data, is it arranged from smallest to largest? Yes, I think so, because we've got 16, 28, 41, 41, 42, 52, 54. Yes. Write down the mode of the data. What is mode? The number that appears the most. So as you can see, 41. So it means the correct answer for 1.1 is 41. That is the number that appears the most. Identify any outlier. Right, so we said for outlier we are going to use our formula Q1 minus 1,5 interquartile range, right? Q3 plus 1,5 IQR. All right, I know it will be seems as if you have to do a lot of work in order to find for 1 mark, but it's worth it, guys. So what is Q1? Q1 we said is our lower quartile. So let's try to find Q1. Q1, remember, 25%, which is equivalent to 1 over 4 n plus 1. Okay, 1 over 4, our n, remember they said 14 participants, so that is 14 plus 1. So this is equals to 1 over 4 into 14 plus 1. This is equals to 3,75. Then you round it off. This is 4, right? When you round it off. So at position number 4, we have 1, 2, 3, 4. We have 41. Therefore, 41 is our Q1. And then what is Q3? Q3, 75%, which is equivalent to 3 over 4 n plus 1. This is therefore equals to 3 over 4 n 14 plus 1. Okay, and then 3 over 4 into 14 plus 1. This is equals to 11,25, which is equals to 11 when you round it off. So at position number 11, 5, 6, 7, 8, 9, 10, 11. Therefore, 60 is our Q3, which is upper quartile. And then what is our interquartile range? That is Q3 minus Q1. In this case, Q3 60, right? So it's 60 minus Q1 41, and therefore this is equals to 19, right? So let's substitute Q1. We found it to be 41 minus 1,5 IQR, it's 19. Q3 it's 60, yes, plus 1,5, 19. All right, and then 41 minus 1,5 multiplied by 1,5 multiplied by 19, that is 12,5. 60 plus 1,5 multiplied by 19, that is 88,5. So any value that is not within this interval should be an outlier. Okay, so let's go back. Which value? Okay, let's erase this. Please check your interval from 12,5 up until 88,5. Which value is not within that interval? 16 is within, 28 is within, 41 and all of that, up until 99 is not within that interval, because our interval ranges from 12,5 up until 88,5. So 99 is outside our interval. Therefore, what is 99? 99 is our outlier. So that is how you identify an outlier, and then determine the median of the data. We have 14 participants. Remember, 14 is an even number. So if it is an even number, you will have to remember, you can use two methods. Okay, you can use two methods to determine the median. So if it is 14, 14 divided by 2, it's an even number, right? This is 7. So at position number 7, from the left hand side, 1, 2, 3, 4, 5, 6, 7, we have 54. And then at position number 7, from the right hand side, 1, 2, 3, 4, 5, 6, 7, we have 55. So we've got two middle terms. That's what I said earlier. For even number, you will have two middle terms. In this case, that is 54 and 55. So you need to add. Okay, 1.3. You need to add 54 plus 55, then divide by 2. Okay, 54 plus 55 divided by 2. This is equals to 54 comma 5, which is equals to 55. Okay, therefore 55 is your median. Yes, 55 is your median. But what if someone else use this? 1 over 2, we know a middle term contains 50%, which is equivalent to 1 over 2. 1 over 2n plus 1. That is 1 over 2, 14 plus 1. And then this is equals to, I think it's 7.5. So let's verify. Yes, 7.5, which is equals to 8. Okay, so 8 position. At position number 8, we have 55. I think you guys can see that. So it's 7, 8. Therefore, 55 is your median. So you can either use this method or this method. But remember, for this one, if you have an even number, you will have to work, okay, by adding those two middle terms and then divide by 2, and then you get your median. Okay, but if it's an odd number, it's very simple. You just divide that odd number by 2 and then check that the position. Okay, and then determine the interquartile range. I think we did that. That's for 3 marks. I think we did that. Yes. 19, we got 19. Okay, draw a box and whisker diagram using the number line provided in the answer book. Okay, box and whisker plot. 5 number summary. Minimum value, yes, lower quartile, median, upper quartile, and maximum value. So what is minimum value in this case? So of course, just like I said, it's not gonna be accurate because I'm not using a ruler. Please ensure that you use a ruler. And yeah, so 16 is our minimum value. 16. What is our lower quartile? Lower quartile, 41. So I'll just say 41. And then what is our median? We calculated median here, 55. Yes, 55. And then what is our Q3? 60. Then lastly, our maximum value, the highest value, 99. 99. Therefore, you can do your things there. Okay, I know the last question says comment. Yes, comment on the skewness of the data by using the box and whisker diagram. In this case, my box and whisker plot is not accurate, so I cannot just identify by looking, okay, because I don't have a scale. I just, for the sake of drawing, in order to show you how to draw a box and whisker plot. But please ensure that you choose the correct scale. Maybe you can use the scale of 5, 10, 15, 20, or maybe use the scale of 10, 20, 30, and all of that, or 15 maybe. So I will find mean. Remember, if mean is greater than median, positively skewed. If mean is less than median, negatively skewed. If mean is equals to median, symmetrical skewed. Okay, so in this case, let's add all the values. Mean, we need to find the sum of all values, so that is 16 plus 28 plus 40 plus 41 plus 41 plus again 52 plus 54 plus 55 plus 58 plus 59 plus 60 plus 62. All right, and then plus 64. Okay, plus 64 plus 99, then divide by the number of values, which is 14. Okay, so my mean, average mean, is equal to 49,21. What is my median, or how much is my median? 55. Yes, so as you can see, mean is less than median. So this means that our skewness is negatively skewed. All right. Okay. Very, very simple. So for standard deviation, yes, standard deviation. So let's try to find the standard deviation. In this case, we said the standard deviation is a number that represents how far a set of numbers have spread from the mean. Okay, so in this case, how can we try to find standard deviation? We can use a calculator to find the standard deviation. Let's say we want the standard deviation of this given data. So on your calculator, scientific calculator, press setup or mode there, mode setup, and then you will see 1 comp 2 stat 3 table. Then you press 2, which is stat, and then after that you will get number 1, which is 1 minus VAR. Then you press 1, then you put your values there. So it's 16, and then you say 16 equals to, then you say 28 equals to 41 equals to 41 equals to 42 equals to 52 equals to 54 equals to 55 equals to 58 equals to 59 equals to 60 equals to 62 equals to 64 equals to, and lastly 99 equals to. Then you press AC, then after that you press shift and press 1. You press shift then 1, then it's going to show you type, data, sum, VAR, minimum, what. Yes, it's minimum, maximum, and then you will say 4. You will press 4, VAR, so that is 4. Then as you can see, the symbol for standard deviation there, number 3. Then after pressing 3, you will say equals to, then in this case our standard deviation is equals to 18,57. So of course we use a calculator to find rather standard deviation. Okay, so that is standard deviation, a number that represents how far a set of numbers have spread from the mean. Okay.